learning about the trapezium rule. In order to understand the trapezium rule, you need to know how to find the area of a trapezium. This should be M2 prior knowledge. Let's just quickly go over it. So let's say we've got a trapezium. A trapezium has a pair of parallel sides and a vertical height. We're going to call these A and B and H. A happens to be the smallest of the two parallel sides. Now, if for whatever reason we wanted to repeat this blue trapezium and then rotate it, I'm going to show you how this works now. We are going to have two trapeziums which are identical side by side. So we'll have one trapezium on the left and one trapezium on the right. If we were then to relabel the sides, we are going to have B at the top, A at the bottom, and the height is still going to be the vertical height, H. This has now become a parallelogram. The reason why it's a parallelogram is because we have two pairs of parallel sides. We have the top and the bottom, that's one pair, and then we have the two sides, they're also parallel. What we want to then do is talk about how we would find the area of this parallelogram. Well, like the area of a square or a rectangle, you find the length of the base or the length and then times it by the height. So the overall area of this whole shape is going to be as follows. 8 plus B, which is the length, times the height. But what we want to do is find the area of the trapezium. Now the area of the trapezium is just half of the area of the parallelogram. So we take the A plus B, which is the length, times the height, and then finally we divide by 2. So if we were to find the area of this trapezium, we are going to have 3 plus 5, which is 8, times by 6, which is 48, divided by 2, which is 24. So our answer for this would be, as I've just explained, 24 units squared. Just to recap, a trapezium can be made into a parallelogram if you copy and paste the same shape and rotate it 180 degrees. Because the area of a parallelogram is the height, which is H, times the length, which is A plus B, to find the area of half of the parallelogram, which is just the trapezium, you need to find half of A plus B times height. Now let's apply this into practice into integration. We're going to be having a look at, to begin with, approximating areas using the trapezoidal rule. So let's have a look at this question. This question involves finding the area under a curve over the interval 4x12. So x is between 4 and 12 with the x and y values given. Effectively, what you need to think about is the trapezium rule looking like this. You have a curve, and then by integrating or using this rule, you're going to find the area of y0, y1, y2, y3, y4, or the area of all the different sections. These are trapeziums because we've got the two parallel sides of vertical, and the height is just going to be 1 unit jump. Two parallel sides, 1 unit jump. So let's see how this works in practice. So for this question here, the first thing we need to do is we notice that we are going up in 2s for the x. So when we're going from one coordinate or one vertical line to the next, we're going to be going up in 2s. The height is going to stay fixated at 2. Then we need to work out, well, what is going to be our A and what is going to be our B? Let's have a look. So if we were to find the area of the first trapezium, this is going to be between the following. Let me draw a quick sketch of this. Let's imagine our curve looks like this. And let's say we're going to start at number 4. We call this number 4. And then we need to find number 6. Let's say this is number 6. And the trapezium rule doesn't work exactly because actually you have to then create a straight line here. So it's not going to follow exactly to the curve if you're creating a straight line, but effectively what it's doing is creating this as A and B. This is A, this is B, and then the distance between 4 to 6 is the height. So we substitute that into the formula. We do A plus B, so we are going to have A is going to be the first value, so the y value. Let's make this a little bit shorter so it's actually linked to the question. So A is going to be the vertical height. Let's say this is going to be 5. B is going to be the vertical height. This happens to be the longer one. So this distance from here to here is 5. The distance here from here to here is 13. So we add these together. 5 plus 13 is 18. Divide by 2 is 9. 9 times 2 is 18. So the area of the first trapezium is going to be 18. And then what we will do is repeat that process several times. So we then repeat it for the second rectangle. And if you don't really want to know how this works, all you need to do is add together the two y coordinates, divide by 2, then times by the difference between the two x coordinates. So let's do the next one. Add together the two y coordinates, 23, divide by 2, times by 2. Add together two y coordinates, divide by 2, times by 2. Because the jump in x's happens to be 2, the divide by 2 and the times by 2 actually cancel out. This 2 is not always 2, but this half is always half. If you want to remember what this rule is, we have talked about this in the YouTube video. It's half A plus B, where they're the parallel sides. In this instance, they're going to be the two y values, times by the height, which is the difference in the x values. So that's y value 1, y value 2, times by the height. We then repeat this for the trapezoid 3. So we get the area of 13, then for 4, which is 7, and then we add together all the areas. We're going to have 4 areas as so. There is an easier way of doing this, and I'm going to show you now. Effectively, what we are looking at is the rule being it's half times h, the first y value plus the second y value plus the second y value plus the third y value plus the third plus the fourth plus the fourth plus the fifth. We're just repeating and we're continually adding these different values. When you expand out this bracket, what you find is that you have the very first y value, which we call y subset 0, is repeated once, and the very last one is just repeated once, and everything else is repeated twice. So the overall formula is going to be half of h times by the first y value plus 2 of all the other y values and then plus 1 of the last y values. Let's see this in practice. So this is our question and we need to think about this particular formula here. And I would recommend not memorising this formula, but really understanding how it works in practice. And let's see how they apply this to the question. The first thing they do is they write down all the coordinates. Now, you don't need to necessarily do this, but this would be quite helpful because then you can substitute it into here. Because like we were talking about in the previous question, the y values are going to be listed in the table of the different y values, and the h is going to be what we're jumping up in the x's. So first of all, what we're jumping up in the x's, 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7. H is just going to be 1. So we're going to substitute 1 into this formula. Then, Alexa, stop. What we're going to do is we're going to replace in the formula the first y value, which is 4. and then we're going to add 2 lots of the second one, 2 lots of the third one, 2 lots of the fourth one. We're going to add all of these together and then add the last one on its own. But the way it does this is slightly different. It takes the first value, which is 4, adds it to the last value, which is 4, and then adds 2 lots of everything else. I will show you now. So we've got the following. Half times 1, and it's 1 because the x's are going up in ones, and therefore the height of our trapezium, this question it was 2 because the height was going up in 2s. This is just going to be half the distance, so it's going to be 1, plus all of the values together. We take this value 4, we add it to the last value 4, and then we times 2 of all the other y values. And that's another way of applying this rule. So our answer is going to be 14.8 metres squared. Now have a look in your formula booklet to see what formula is given to you. Now what I'd like you to have a go at is some of these questions on the screen now. Good luck.